Good morning. This is a very interesting problem. Say a number of subsets in a superset that makes a sum k. That make a sum k. For example, we are given a superset 1, 2, 3, 4, 5, and sum required is 5. The number of subsets that can make sum 5 are 1, 4, 2, 3, and 5 itself. The answer is 3. I hope you understand it. This can be better done by an excellent technique by name DP, dynamic programming. Here we solve the problem incrementally and using previous solution to develop current solution. The given set has 5 elements. And sum to be made is say 5. What we do is we create a matrix. With k plus 1 rows and s plus 1 with k size of k plus 1 columns and size of s plus 1 rows starting from 0. So how many rows we have? Row 0, row 1, row 2, row 3, row 4, row 5. Then k is 5, k plus 1 columns. So we have 0, 1, 2, 3, 4, and 5. Hope you understand it. Now, to make subset 0, with element 0, with number of elements 0, with 0 elements, is it possible? If possible, put 1. A subset of some 0 can be made with 0 elements. Can we make a subset of 0 with 1? With first element? Yes. Because you have two options. By not keeping that element in the subset, you can make. Now you have two elements, 1, 2. Can we make a subset of 0? Yes. By not placing it, this is 1. Okay. Now, with 3 elements, can we make a subset of 0? Yes. Problem of plenty here. With 4 elements, can we make? Yes. With 5 elements, can we make? Yes. With 0 elements, can you make a sum of 1? No. With 0 elements, can you make sum of 2? No. Sum of 3? No. Sum of 4? No. Sum of 5? No. So using these base solutions, we can develop. What is this? Using element 1, can we make sum 1? Can we make sum 2, sum 3, sum 4, sum 5? Using elements 1, 2, can we make sum 1, 2, 3, 4, 5? Using 3 elements, using 4 elements, using 5 elements. Okay. Finally, using 5 elements, in how many different ways we can make a sum of 5? Here we get an answer 3. Okay, so let us do it by writing a program and creating a 2D matrix, generally called as DP, but I call it as solution matrix. Let us go to our advanced Java compiler. Input is superset. Say yes. Have 5 elements. Sum to be made is k. Now the function name is, the method name is subsets. Inputs are superset and the required sum. Now let us create a public static method. Public is not enough, not required. Static is enough. Returns integer. Okay, and name is subsets. Inputs are superset and the sum required. First of all, find out the size of superset. Then, as I told, create a solution matrix of size of rows n plus 1 and columns k plus 1. Okay, now all of them are initialized to 0 by default. Now first column should have ones. How do you do it? First column, what changes? Rows change. How many rows? 0 to n rows. And what is the value of the solution matrix? The 0th column is 1. Okay, so this column is made, right? And you need not fill others as 0 because by default they are zeros. That's the advantage of new operator. Now for remaining rows and remaining columns, what are the remaining rows? 1 to n, sorry, remaining columns 1 to k, remaining rows 1 to n. So for rows first, 1 to n, and then columns, n columns, 1 to, column is represented by j, 1 to k. Okay, now if j is a subsum, j is a sum, if you can place what is I? Number of elements. I is number of elements. For the first element, what is the index? 0. For the first element, index is 0. For ith element, index is I minus 1. If this element can be placed in the subset, when can you place? When the required sum is more than this. If required sum is less than this, you cannot place. If you can place it, then you have two options. You have two options to place I elements in the set. One is don't place it. One is don't place it. Second is place it. Okay, by placing, the sum will be reduced by the element. Okay, now these are the number of ways by not taking that element. These are number of ways for taking the element. Now you want total number of ways, right? Just add them. Okay, otherwise, that is, if the element is bigger than remaining sum, then don't place it. Then your solution will be I minus 1j, because you did not keep that element in the subset, so sum will not change. That's it. Now, what is the solution? We just return the solution, that is number of ways for keeping n minus 1 elements, that is 1 to 5 elements, 1 to 5 elements, n elements, sorry, n elements, to make a sum k. Solution I0 equal to 1, sorry. Oh, rest is perfect. So how many ways? 3 ways. What are they? 2, 3. First 1, 4, and then 2, 3, and then 5. Okay. If I remove 5, then there are only 2 ways. What are they? 1, 4, and 2, 3. Is this clear? So please practice. This much simple the program is. I hope you understand it. Thanks for watching. I take leave.